This is section 2, part 1 of the Ghost Onshape onboarding video series. This video assumes that you've completed the previous sections. This video does not cover the overall design process and workflow. That will be saved for a separate video. As mentioned in section 1, assemblies are sets of parts and their interactions with each other, and part studios define parts for use in assemblies. Assemblies can also be used as sub-assemblies in other assemblies. To start, let's make a new assembly. We create a new assembly by clicking the New Tab button, then clicking Create Assembly. On the left here is the assembly list panel. It includes all part instances, groups, mate connectors, mates, and relations defined for the assembly. We can insert parts in other assemblies by clicking the Insert button, navigating to the part or assembly, clicking it, and clicking in the area that we want to add it. To add standard VEX parts, go to the Other Documents tab. If you saved the part libraries properly, the official VEX v5 library should show up here. Some parts will also have configuration variables, allowing you to change certain properties of the part. Let's add a couple C channels and the cube we made in part 1. Click the check mark to confirm. Let's take a moment to understand what these are in the toolbar. This is a mate connector. We only add mate connectors when we need to connect a part to something that's not on an existing part. There are a few uses for adding mate connectors that we'll cover later, but you generally don't use this button. These here are mates. They constrain parts' movements in relation to one another. Mate connectors are not the same thing as mates, and making a new mate connector for every mate will quickly clutter the assembly list, making things more difficult later. The most commonly used mates are fasten, revolute, cylindrical, and slider, but I recommend experimenting with all of them to get a feel for what they do. Let's start by using a fasten mate to connect a C channel to the origin. Connecting a part to the origin helps keep things in place when you don't want them to move. Press M or click the Fasten Mate button to add a new mate. As you hover over parts, you'll see these dots. We want to connect a screw hole to the origin, but just hovering your mouse over that won't let you select it. For this, all we have to do is hover over the surrounding face, hold Shift, and then move our mouse to the center of the hole. Now you should be able to click the dot there. Click the spot you want to attach it to, in this case the origin, to fasten them together. The origin can be a bit finicky to get the right direction for, so make sure that when you click it, the blue line is pointed up. Click the checkbox to confirm. Now that the C channel is fastened to the origin, let's try and connect the two C channels together like a hinge. We'll do the same thing that we did the first time, except now we'll use a revolute mate. We'll select a hole on the C channel, then the spot we want to connect it to. Click the checkbox to confirm, and now these look like they're connected. If you click and drag this one around, then it will rotate while the other one stays in place. This is why we fastened the first one to the origin. Let's go ahead and fasten this cube to the C channel as well. Now, let's see what happens if we try to make the two mates conflict with each other. When I connect this cube to the other C channel, I can click Solve to check what happens when it's applied. You'll see this red circle in the assembly list, and the affected mates will turn red. We should never leave errors like this in a final assembly, as it can cause unpredictable behavior. If you cause errors, then you will be asked to fix them. Now let's cover one common use of adding a mate connector in an assembly. Let's say you want this cube to rotate over here. There's an option to offset a mate, but for revolutes, this only works in the Z direction. We want it to be over here without adding any parts that have their own connectors. In this case, our only option is to add a mate connector. Let's add the mate connector, check the move box, and move it a few inches on the x-axis. Confirm it, and now we have a mate connector that we can use for a revolute mate. There aren't many situations you'll need to do this in, but sometimes it's the only way. With just these basic tools, you can assemble an entire robot in Onshape, With just a few more, you can even develop complex gear trains and linkage systems for sub-assemblies. This concludes Section 2, Part 1. You can now start developing basic assemblies for robots. In the next part, we'll cover gear relations and custom linkage systems.